Hello guys, welcome back to another video. Today we'll be looking at organic chemistry part. So first we'll be looking at alcohols. The alcohols form a homologous series. Like all the homologous series, the alcohols have the same general formula. They differ by CH2 molecular formula from neighboring compounds. They show gradual variation in physical properties such as their boiling points. They have similar chemical properties. Functional group. The functional group in the alcohols is a hydroxyl group minus OH. It is responsible for the typical reactions of alcohols. So some familiar alcohols, alkenes and alkanes are ethane, ethene, ethanol, propane, propene, propanol, butane, butene, and butanol. And if it ends in OL, it's an alcohol. Making ethanol by fermentation. The typical conditions needed for fermentation include sugars dissolved in water and mixed with yeast, an airlock to allow carbon dioxide out whilst stopping air getting in, warm temperatures, which is about 25 to 35 degrees, or usually 30 degrees. So the reaction takes a few days and the ethanol formed has to be separated from the other substances in the flask. The yeast starts when the ethanol concentration reaches about 15%. Fermentation is a slow reaction and takes several days or weeks to finish. If air is present, the oxygen causes the ethanol to oxidize to ethanoic acid, so the drink tastes of vinegar. Reactions of alcohol. So now we're looking at different reactions of alcohol, which are combustion reactions, reactions of alcohol with sodium, water, and oxygen. Combustion. The alcohols undergo complete combustion to form carbon dioxide and water as they burn oxygen. Ethanol is used as a fuel. So ethanol plus oxygen goes to carbon dioxide plus water. C2H5OH plus 3O2 goes to 2CO2 plus 3H2O. When less oxygen is present, the incomplete combustion will occur, producing less water and either carbon monoxide or carbon. Guys, so now we'll be looking at more reactions with alcohols, and we'll be looking at reactions with sodium. If a small piece of sodium is dropped into ethanol, bubbles of hydrogen gas are produced, and the liquid contains sodium ethoxide. The reaction is sodium plus ethanol goes to sodium ethoxide plus hydrogen. 2Na plus 2C2H5OH goes to 2C2H5ONa plus H2. So methanol, propanol, and butanol, the other alcohols, also undergo similar reactions. So now we'll be looking at another reaction of alcohols, which is the oxidation of alcohols. The alcohols can also be oxidized without combustion to produce carboxylic acids. For example, ethanol can be oxidized to ethanoic acid using an oxidizing agent. So the equation for this is ethanol plus oxidizing agent goes to ethanoic acid plus water. So CH3CH2OH plus 2O goes to CH3COOH plus H2O. Now we'll be looking at carboxylic acids. The carboxylic acids form a homologous series. Like all homologous series, the carboxylic acid have the same general formula, differ by CH2 in molecular formula from neighboring compounds, show a gradual variation in physical properties such as the boiling points, and they also have similar chemical properties. Carboxylic acids. Carboxylic acids are weak acids. This means that their solutions do not contain many hydrogen ions compared with a solution of strong acid with the same concentration. The pH of a weak acid will be higher than the pH of a strong acid if their concentrations are the same. Also, weak acid means that only a fraction of the molecules break down into ions when added to water. And because they're weak acids, they do not harm us when we eat or drink them in small amounts. Thank you for watching. I hope you enjoyed my video. Please like my video and subscribe to my channel, and look out for my other videos.